All right, welcome back to E75. This is lecture 6, continuation of SQL. So the goals of tonight are to talk about third normal form, though perhaps not in that language, but to continue the conversation from last week about databases and actually solving some problems using an actual database engine. We'll look at some more sophisticated techniques that you can employ using MySQL or engines like it, and then we'll conclude with a look at project 2, and how you might go about designing your own tables and solving the problem that is CS75 finance. We were chatting before class about the work that some of you have done very successfully financially. Looks like Hung is up at 312% up, having started at 10%. Might very well be some very savvy investing. We can look at the history here. Might also be a little after-hours trading, not to be too pessimistic, given that this all happened at the same day within a few minutes range. Seems like Hung might have gotten really interested in this and then lost interest after making a lot of money on what appeared to be some penny stocks. So that's cool. That's all right. Let's see. And then some of us are down here. Oh, am I in that company anymore? Nope, I'm doing a little better today. Where's Malin? Oh, wow. Okay, I'm only in the credits now. Wow, okay, I've dropped off myself. I'm doing really poorly then. I seem not to have passed our threshold with my single penny stock. So a few of you have some work to do, but again, this is just for fun. And it's also meant as a demonstration of what you can do for this project, because you'll see if you log in our actual interface for this thing. All right, so we left off last time talking about login mechanisms. And we had improved significantly upon where we began, login mechanisms, which was just hard coding in some constants, username jharvard, password crimson, which really didn't do anyone any good. So we finally introduced last week this notion of a database that stored usernames and passwords. So we had a little interface that looked like this. Let me go ahead and pull up tonight's version. I went ahead and reprinted some of the code that we didn't focus on last week, so you have either last time's printouts or this time's. And the interface we looked at was a little something like this. And we had 4 different flavors of this, and we concluded with 6 of 8 here. So what we didn't do was this. Let me go ahead and go over to version 6 of this. So this is login 6, and this is where we left off. So I had proposed this slight optimization, or this principle, of not necessarily selecting star, getting back all of the data that you might possibly care about in the database, and then doing the logical checks yourself. But I proposed, you know what, we have an actual database engine now. We can tell it to do the searching for us. And so I proposed that, you know what, why don't you just try selecting something arbitrary but compact, like the value 1, if you find both a username and a password that the user has provided. But I took care, recall, to escape both of those strings using this annoyingly long named function, MySQL real escape string, which essentially quotes properly or escapes properly any dangerous quotes. And we'll talk more about that in our security lectures. But for now, trust that this is in fact a very good habit to get into. And then what would I get back? I get back this thing called a result set, generally speaking. This is a MySQL result in the context of PHP. And then I simply checked for the number of rows that were returned. Because what did it mean last week if MySQL num rows, when given this result set, returns 1? What's the logical implication? They found the username and the password, because by selecting 1, I'm essentially asking MySQL to just give me 1 row and 1 column containing just the number 1 if, in fact, this username and password are found. And we can replicate this now. So one of the advantages of playing around with PHP-MyAdmin is not only to administer your database, but you can also execute queries, check your own syntax, because this will very clearly bark at you if you make a syntactic error, whereas executing it within PHP, you're going to have to write more lines of code to see those errors. So let me go ahead and try this same idea. So I'm going to click the SQL tab. I'll go ahead and zoom in here. And I'm going to go ahead and select 1 from users, where user equals, I'll pretend to be jharvard, and pass equals 1, 2, 3, 4, 5, I believe it is. All right, so let me zoom out. I'm going to go ahead and click the Go button here, down at bottom right. And voila, what comes back is an empty result set. So what is in fact wrong here? My password is not that. Let's go to browse. What's my password? Okay, so it's crimson here. So jharvard is the username, and pass was crimson, not 1, 2, 3, 4, 5. So let me go ahead and try that again. Easy fix. Let me go ahead and type in crimson, and notice a few key features. So single quotes around strings, and I've taken this approach of uppercase for keywords and lowercase for non-keywords, table names, field names. It's really just a convention, the uppercase, but I would propose that it makes it a lot easier to skim what's syntax and what's actual data. So let me go ahead and click Go now, and what I get back, stupid though this looks, is a table, a temporary table, if you will, that's one column and one row. So that's why logically I can just check that for MySQL numRows equals 1, and bam, I know I got back an answer. Because what happens if I make a mistake? If you paid attention a moment ago when I accidentally did 1, 2, 3, 4, 5. If I have a wrong password or just garbage for the password and click Go, well, what comes back? Well, nothing. So MySQL numRows would be 0. So that's where we left off last time. Any questions? No? Okay. So what room for improvement is there? Well, this is wonderful for lecture demonstrations and for forgetful memories, because I can just check what was J. Harvard's password. But if you call a typical IT help desk or any corporation these days, odds are, even if you've forgotten your password and you tell them what your name is, your social security number, where you live, no person on the other end of the line is going to be able to tell you, oh, your password is such and such. In fact, most websites do what if you've forgotten your password? So they let you reset it. They don't let you see it. They let you reset it. Now, why is that? Well, they're not just being difficult. They, odds are, cannot mathematically recover your password because they've actually encrypted it in their database. So this is clearly unencrypted. Why bother encrypting this? I already logged in. I had to log in to see this information. So what's the point of adding this layer of encryption to these passwords, do you think? Oh, sorry. All right, so it can't be looked at over the wire. So if I'm actually querying my database over the internet, it will just look like nonsense going across the wire. I would say that we don't need to encrypt it at the database level, though. I could just use SSL or something like that to encrypt the whole connection. So what else might there be? So valid, but not necessarily the end-all. Yeah? Yeah, I mean... Yeah, do you really want any employee at Comcast or Facebook or wherever to be able to see what your credentials are and then log in to your account with them and poke around? Yeah. And so this is maybe the biggest one. I mean, I've lost count over the past several years how many times you read in mainstream media that some big company lost its database and some laptop was stolen which had a database on it, all these stupid scenarios that boil down to just the data getting compromised. Now, it's unfortunate if your whole database gets stolen. So even though this is a database, but a database is just files at the end of the day on a hard drive, or just text files even, they can be compressed in all of this. So it's very easy to steal a database if you have physical access to the machine, or you break into the computer account and can then copy it from to somewhere else. But it's unfortunate if your database is stolen. It's a lot more unfortunate if the data inside of it is actually useful to someone else. So all the better if it's unfortunate if your name gets compromised, maybe your phone number and all of this, but at least let's hope that 1 million credit card numbers are not sitting there raw in clear text. Let's hope that 1 million passwords are not just sitting there, because that just really lowers the bar, certainly, to the account being abused and compromised. So a lot of companies, and ourselves included, will start to encrypt this password field. Now, the downside is if the human forgets what their password is, mathematically, typically, you just can't recover it. But that's one of the upsides of this same process. So let's see how we can do that. Let me go ahead into version not 6, but version 7 of this, and scroll down. And notice I made just one change to the code. A good question. So, and we'll see this in a moment, but it turns out that you can use encryption in just one way, in the following sense. So I register for Facebook.com, I give them my email address, and I give them a password. They, like most websites, probably encrypt it and then store the encrypted version in their database. So now the next week I come to log in, just for typical usage, to view my newsfeed and all that. So I log in with my email address, I type the same password in clear text on my computer, I hit enter, it gets transmitted to Facebook as I typed it, albeit using SSL, so the whole thing is encrypted, but not the individual password. Upon receipt of that password, what could they do to nonetheless authenticate me? Exactly. Use the same function, encrypt what I just typed for the second time, and then if they match, well, I must have typed the same thing both times. Now, that's a bit of a white lie, because usually the functions being used to encrypt passwords are actually not two-way encryption. They're one-way encryption, or one-way hashes, which means you take what the user typed and you convert it to something very cryptic-looking, but with some probability, but very low, could two different passwords actually hash to the same value. So in theory, with sites like Facebook and my own, it is possible, but very, very unlikely, that I could type both foo or bar into my password field and be allowed to pass. But this happens if you use the right kind of mathematics. I mean, 1 out of every 4 billion passwords might actually be the same. So it's probably even safer odds than the odds of my taking like a car key and walking into Harvard Square and just trying this on the same make and model as my car, which, I mean, you can do. There's only so many keys you can make out of metal. So it's the same idea there. But mathematically, we have much safer odds. So really good question, and very common. Even etc password on a typical Linux system functions in exactly the same way. You store the ciphertext in etc password, and you just re-encrypt the user's input every time and compare. All right, so it turns out that MySQL comes with a password function. I've written it here in all caps to be clear. So I'm implementing exactly the same idea. When the user has typed in their username and password to our little form submission, again, to be clear, the context is a simple application that this will break in a second. Let's use the version that has my password fields from last week. Whoops. So what we have, damn it. So the user has just typed their username and password in here. They've hit enter, and so the code that's now going to execute is going to, again, select one from users, where user equals this particular string, and password does not equal the raw input that they typed in, but the result of calling this, all caps, password function, the input that the user did provide. So this is going to create something funky looking. So let's actually try that. So let me go back to my PHP MyAdmin window. Let me go ahead and click my SQL tab, and let me do something like this. Let me just select, it doesn't really matter what I do, password of Crimson from users. All right, let's see. It should behave okay, even though that's a little nonsensical. So this is what I just got back. So I selected it from users, but I just needed a random table to choose from because I'm not actually selecting data. So that's what my encrypted password would be. So this is what I should really be storing into my database. All right, so when a user registers for my account, apparently what I want to do is first call this function. Then I want to copy and paste their output. And then in my database, do I actually want to store not a varchar in this way here? Let me go ahead and edit this. And typically what one would do here is put like a blob. Binary large object, silly name, but that's what it denotes. And if you read closely in the documentation, you'll see typically what kinds of functions require what data types. So we don't want just varchar. We could get away with it in this case if we made it sufficiently large. But what I would want to do now is define this field to be a binary field, not actually a raw text password field. And if I wanted to manually now change this user's password, what I would actually, it's somewhat obfuscated now because the PHP MyAdmin can't show you binary data very easily. And actually, I can't input it very well manually. Sorry, let me go back here. So now what we have is a database structure that looks like this. So now when I actually implement the registration feature, which we don't have here, we just have the login mechanism, what do I need to do to insert a new user into the database? What is the SQL query that should be executed? Anyone recall the general syntax from last time? Insert into, yep. Users. And then you can specify, this first part actually isn't necessary. If you already know the order in which all of your fields were defined, you can just jump right into the values. I would say as a matter of principle, this tends to be safer because you don't make any assumptions as to where the fields are. So enumerate them, user pass, and now values. And then I can do something like J Harvard, and then something like that. But how do I generate this? So I'm certainly not going to be doing this manually. So really what I want to be doing is inserting the result of calling password on whatever the user actually typed in. So user provides J Harvard, user provides Crimson. I then execute in my PHP code a statement like this, which should insert that new row into my database. And then henceforth, when I actually try to authenticate this user with my login mechanism, that's when this code now will in fact start working, because I'm checking by passing the same value in as I did when the user registered. Nope, it is a MySQL function. So most of these database engines come with some helper libraries, much like a typical programming language would, and password is one of them. Yeah?
Just happened to be in one of the MySQL documentation that password should not be used and it's used only for MySQL authentication and should not be used in other applications.
Good. Perfect segue to example 8. So though several of you did take some very good notes, I'm sure, there, best practice does say these days don't use password. So the reality is it actually makes the explanation, I think, of this last example a little more palatable. But password is a fairly weak cryptographic mechanism. It's relatively easy to crack it, more so than other algorithms these days. So in fact, MySQL comes not only with this password function, which again generally shouldn't be used unless you're making little toy websites for which it's really not important, but it also comes with a suite of functions like AES, Advanced Encryption Standard, which is much more state-of-the-art these days. So the usage here has to be a little different by nature of it. AES encrypt is actually an encryption function, not a hash function. So the password function creates this thing called a one-way hash. You give it input, it produces output, but you can't go from the output back to the input. It only sends it in one direction. But as the name of this function at middle right here, AES encrypt, suggests, there's a suite of functions, one of which is AES encrypt, one of which is AES decrypt. So that's actually a good thing because you can reverse this process, and I'll offer this approach as one possible stronger implementation of the same password idea, the goal of which is to be able to encrypt the data in my database without using the password function, but in a manner that I can reproduce. So a typical approach in cryptography or security is often to introduce randomness when you want to make something harder to crack. Unfortunately, randomness is bad if you need to reproduce exactly those steps, which you do need to do when logging someone in. So we can't just, for instance, add some randomization to this and then expect that it will work, because we need to somehow produce that same random noise the next time around when the user logs in again and again. So one way we can accomplish the encryption of this data is as follows. So when I actually register the user, or conversely, when I actually try to log them in, I could assume that their password has been encrypted with AES encrypt. But there's a downside here. AES encrypt, as you might be able to infer here, takes two arguments. One, the string to encrypt, and second, the password to actually use to encrypt that data, or the key to use to encrypt that data. So this will work. This will return a big string of nonsense, which is good because it means it's hard to reverse. But what's a downside of this approach? Yeah, so now my database is secure if stolen, but now the bad person just has to get my PHP source code too. They know what my password is. It's apparently quote-unquote secret, and now they can just reverse the encryption and all of those files. So this actually lends itself to an interesting thought question now. So AES encrypt is pretty strong cryptographically. What does that mean for us? Just means it's pretty hard relative to other algorithms these days to brute force your way through it or find some weakness whereby you can figure out someone's password without trying all possible passwords. Right? That's a good situation if the hacker has to try all possible passwords, because if you choose a long enough password yourself, it's going to take him forever. I mean, more minutes than there are in our lifetimes to find that password. So we want to use AES encrypt because it gives us those stronger properties, but we can't do something stupid like this. We can't pass the password in this way. So can anyone propose a clever use of the same building block that avoids hard coding in some known password? Okay, so we could use a variable there, but where are we going to assign the variable of value? Just higher up in the file? Hope he doesn't scroll. So it's a good thought, but not sure that alone gets us far. Okay, so configuration file. So let's move it a little further from the file, and I'll be the jerk and just say, well, fine, now he just steals the whole directory. So, interesting. So the goal is to replace secret with an actual secret, but we can't do like a random secret, because then we have to somehow generate the same random secret for that user again and again. But the user already has a secret in his or her own mind. So why don't we simply encrypt the user's password with perhaps the user's password? This is kind of, a little mind bender there for just a moment, but if we encrypt the user's password with their password, the result should be some, random looking string. Let's store that string in the database, because now the next time the user comes back, they're going to try to authenticate. All right, so let's consider the two cases. They provide their correct password. They provide their correct password. We therefore encrypt their password with that same password. We get the same result as we did when they registered. All right, so case 2, they provide the wrong password, so we encrypt the wrong password with the same wrong password. We get a different string of nonsense, so they don't get authenticated, but that's the correct behavior as well. Now, any caveats here or concerns? So you can't decrypt their password if you've forgotten it, because then you literally have a catch-22. Well, user, we can tell you your password if you tell us your password, so we can decrypt your password, right? You can actually see someone reading this off a script probably on Dell.com or whatever, trying to explain that to a user and not appreciating the illogic of it. Okay, so that's fair if that's a feature we want, but generally it's not a feature these days that is desirable because of the theft problem and the nosy employees problem. What's maybe worrisome here? Yeah?
Isn't it true that if you're not using HTTPS, you're still passing stuff in the clear?
So very true. So for all of these lecture examples, I'm not using HTTPS, just HTTP, which means JHarvard and Crimson have been going back and forth. So that alone is bad, but is relatively easily solved just by turning on SSL. Yeah. Okay, complexity of your password. So we still have the fundamental problem that if the user is allowed to have very short passwords, even the bad guy could brute force his or her way through this just by trying all possible encryptions of a word with itself. But at least I can push back and say, well, fine, when they register, let's just require passwords of length 6 or 8 or something that's not in a dictionary. So I think we can deal with that at another layer. So in fact, this is actually a fairly reasonable, clever approach. I should say that it's sort of a reasonable real-world approach. Like in the cryptographic world, this idea of encrypting something with itself actually would make a cryptographer kind of shudder, because even though you can make fairly strong mathematical arguments about the probability of collisions and identical passwords when you take a string and a random password, a random key, it makes academics very uncomfortable if you start coming up with arbitrary heuristics like encrypt a password with itself. Because for today's purposes, you can't make as strong claims mathematically about the uniqueness of the resulting string. But in the real world, that's probably okay. And especially if you have additional mechanisms in place, like if your website, if someone tries to log in with the wrong password like 3 times or 5 times, just ban them. Then you're really raising the bar to compromising an account. Because not only is it probabilistically really unlikely that they'll guess someone's password, they only have 5 chances out of 1 billion or more possibilities to actually get it right. So there's some other defenses there too. So one thing that you can do, you don't have to just use their password, because in fact, there is an interesting exception here. If you let someone encrypt, if you have your website encrypting someone's password with their password, and now you're either a bad guy or a nosy employee, and you skim the list of usernames and encrypted passwords in the database, what can you actually realize that probably is not information you should know? Yeah? Yes, that 2 people have the same password. So maybe this isn't all that useful, because how can you really exploit this? Well, maybe you realize, oh, Jill and Jack have the same birthday. They have the same password. Let's go with, their, birthday. So that's information that doesn't need to be leaked. So if now this is a concern, in cryptography, it generally is a concern. Like you don't want to reveal information unnecessarily. Could we perturb the result in such a way that we don't have this problem? Like I really like the clever idea of encrypting a password with the password, but can we add a little bit of noise, so to speak, that's not really random, but that really diminishes the probability of that? Yeah, throw in the username. So perturb the algorithm by, don't encrypt it with the password. Maybe encrypt it with the username and the password concatenated together, or something silly, arbitrary, but predictable and deterministic that you can recreate again and again and again. How can that safely be recreated? Well, presumably the user, to get in, is going to give you the same username and the same password again and again, so we avoid that problem of using randomness, which would be really hard to produce again and again at different moments in time. So long story short, very simple mechanism, really typical problem, and some very clever solutions that now mean that if someone steals this database, what are they going to have to do to figure out J. Harvard's password? What's that? Yeah, try passwords. I mean, ad nauseum, try all possible passwords. Now, he'll probably get one or more passwords, but if it's a Citibank database of 1 million users, probably not going to get all 1 million of them, maybe a few here and there. So, maybe Citibank doesn't need to incur the expense of mailing out 1 million new credit cards, which is probably expensive. So there's some interesting real-world implications to all of this stuff, too. Hand or two, yeah?
Every minute.
Mm-hmm.
And so not only did you have to log in and password, you have to type a number.
Mm-hmm.
And that was the way you get in. So even though your login and password could be correct, then you have this special thing, this thing would change every minute, which would coincide with what was going on the main
Mm-hmm.
the other side, so that without that, you wouldn't be able to go further.
Yeah, and so this is a really good point, and without digressing, let me summarize for the folks at home here. So yes, so what we're talking about tonight is what's generally called one-factor authentication. And this means you present to the person authorizing you one credential, like a username and password, the latter of which is actually secret. Problem with this is your password can get stolen, the Post-it note with it can get stolen. It's one piece of information that you know, and even in the movies do we see that you can always coerce someone to give you knowledge that they have up here. So a second factor of authentication might be not only to steal something that someone knows, but also something physically that they have. The idea being that you might be able to get one out of the user or the other, but with lower probability will you be able to get something that someone knows and that they physically have. So people carry these key fobs, which have just little numbers that count. It's like usually a 4 to 6 digit number, and it changes every 10 or so seconds. And this is synchronized with the server so that when you go to log into your website or your bank account, there's in New York, I think Citibank might actually use these things if you have the right type of bank account. And E-Trade, I think, has these things, little key fobs. So you go to their website, you type in your username, you type in your password, and you have 10 seconds to type in the current number on your key fob. Then all 3 values are checked server side, and if any one of them is incorrect, then you're rejected, and you have to try again. So the upside of this is that if I lose my key fob, doesn't matter because the thief has to know what I know, which is my actual password. Well, now if my password is sniffed, or if someone's looking over my shoulder at the ATM, they're also going to have to physically mug me and take that key fob, which just means we're just raising the bar. So that's what two-factor authentication is. And I'll say too, I actually have the RSA application on my iPhone. You don't need key fobs anymore. That's very early 2000s. Now you can download programs on phones and Blackberries that do the exact same thing, which is a nice trick too. So other questions or comments? So a lot of responsibility starts to fall on your shoulders if you have to actually protect your sites from bad people getting in. All right, so today's a little more about MySQL, as we've seen. So there's a whole bunch of data types, and one of the fun parts or design parts of Project 2 is figuring out what makes the most sense for your various fields. So I should say, because the data you're going to be working with for Project 2 is fairly limited in scope, you could probably declare everything as a 1,000-character string, and you're not going to notice the difference, because our server's got like 1 gigahertz, 2 gigahertz, it's got plenty of RAM, and you're not going to have that many users using your version of CS75 Finance. So realize that a lot of the design principles we're preaching for this lecture and last, and also Project 2, really apply to projects in general, even though you might not necessarily feel, in terms of CPU time or space, the implications right now. So MySQL has all of these various data types, and generally it's best to constrain your data as best as possible so that, 1, you're not wasting space, and 2, so that you lower the risk of inserting bogus data into your database. If you only want ints for a certain field, well, don't store those ints as strings, because then clearly bad things can happen if non-ints can be inserted to the database. So I've tried to categorize these. At top left, we have the text-related data types for MySQL. I'd say 6 times out of 10, 9 times out of 10, if you need something textual, you're probably going to want to use varchar, variable char. It can be between 1 and 65,000 characters these days, although I still am in the habit of 255, which was the limit for some time. So if you have a field like a person's name, you probably need what for a person's name? At least 10 characters, maybe 20, but there's some really long names out there, maybe 50. You got to draw the line somewhere. The upside of varchar is that, as the name implies, it only uses as much space as is necessary to store that user. So saying 255, even though that's kind of crazy for a person's name, doesn't mean you're spending 255 bytes. So you pick a rule of thumb, 64, 32, whatever number makes you comfortable. But if you know the field is of fixed width, like a password, if passwords must be 8 characters, or phone numbers must be 10 characters, or social security numbers must be a fixed number of characters with hyphens, well then there actually is a design benefit to going with something like char, because if you think about how a database is probably implemented, if you've taken a class on assembly or C or C++ that are fairly low level where you have to deal with memory management yourself, there's this fundamental advantage of being able to tell the computer all of my data is exactly this wide, because it can start doing clever things with like pointer arithmetic and jumping around memory, knowing deterministically that every time you increment by 8, you're going to hit another beginning of a string, another beginning of a string. So there's some fundamental advantages performance-wise if you, the developer, know in advance what your data is going to look like. Teach the database to know that so it can exploit it for performance, especially as your data sets grow. Text fields. So text is actually for longer text fields. So if you are now implementing like an arbitrary notes field for an address book program, where you're not going to really bound it by 255 characters, maybe not even 1,000, because people might like to paste in really big chunks of text into the notes section for their address book. Or, for instance, with the news site that we've looked at briefly in this course, when I actually, to implement full article searches, right now what you're just seeing are the short descriptions from the RSS feeds. But when I actually, every 5 minutes or so, or 15 minutes, scour Harvard's campus for more articles, I do an HTTP request for the article itself, get rid of all this JavaScript and CSS, just get the raw text content, get rid of all the HTML. But that's, could be itself several kilobytes of text if it's a really big article or news story. So those actually could fit in a varchar, but I put them in a text field because the text field actually supports what are called full text searches. So among the features that MySQL has is the ability to search using a slightly different syntax than a quality checking, really big bodies of text for certain keywords. And that's precisely how I implement the news site. And this is one of the features you get with a database engine. Even if you took years ago a data structures class, an algorithms class, there's a lot of fancy ways in this world to search for data, but that's what the people at MySQL are doing for you. That's what Oracle's doing for you and Microsoft is doing for you, is figuring out, given some really big tables and lots of data inside, how can we, the database makers, organize this data and expedite queries of the form select foo from bar where baz. Right, so that's what these databases are doing for you, is trying to optimize work that might be theoretically interesting and even programmatically interesting, but you're just trying to get real work done. And that's the advantage of moving away from just XML and CSV and actually using these real engines. So what else? If you look at the manual, you'll see that tiny text, medium text, long text, these just have different bounds on how big they can be, and there's just slightly different implications for performance. So that's when you read the fine print. Then there's these dates and time fields. So these are quite useful and quite commonly used. Date is just a date. Year hyphen month hyphen day format, although it doesn't actually store the hyphens in the underlying database. That's just how it's presented. Time is hours, hours, minutes, minutes, seconds, seconds, with colons in between. And then you have timestamps, which is just like a number from 1970, January 1st, give or take, although it's defined slightly differently from Linux and Unix. So there's a conversion function that goes from one to the other. But those relate to things like when was this article posted, or when was this row inserted. As you may have seen last time, MySQL actually has some neat features. If you have, for instance, let me go ahead and insert something like this. I'm going to create a new field called created. Whoops, not insert, structure. I'm going to insert a new field after the pass field, and I'm going to call it created, because I realized at some point I'd kind of like to know when users registered for this website or whatever it is I'm making. So I could use date time, but if I use timestamp, I can leverage a feature like this. Under attributes, there's this feature here, on update current timestamp, and this too is another feature you kind of get for free with some databases. What this means is anytime I modify the user field or the pass field, that field will get updated for me. It's just a convenience. I could certainly update the time field myself, but why bother if someone else can do it for me? Same thing with auto-incrementation. When I proposed last week that we have unique IDs to identify important rows in a table, I mean, why should you have to deal with counting from 1 to infinity? Let the database automatically assign these IDs. So auto-increment is useful there. Okay, these are probably familiar from various languages. They all mean different things. They go from small numbers to big numbers. At the top there, we have a few different floating point values. The one I'll make mention of here is decimal. It's actually really nice. It's a data format that's a floating point value, but it allows you to specify how many numbers to the left of the decimal you want to allow and how many to the right, which is wonderful for something like Project 2 in finance, where you care about dollars and cents, because you may recall that anytime you deal with floating point precision in just floats and doubles, whether they're 32 bits or 64 bits, there's just some numbers you can't represent accurately. Kind of a bad thing when it comes to money. Right, you may recall from like Superman 3, really interesting opportunities arise if you have tiny little pennies, or more modernly, Office Space. They stole the same idea from that movie. Anyone see either of these movies? They're both wonderful movies. Anyhow, so bad things happen thanks to floating point imprecision. So decimal's nice when you're dealing with something like money, where you want finite precision for floats. Okay, finally, we've got some binary data types. You'll rarely need those yourself, except when using functions, like certain password-related things that tell you to store something in a binary field. But you can use binary fields to store binary data. So if you're implementing a website that allows users to upload graphics, files, images, you can store them in the database. And this is one of those topics where if you Google it, you'll see one camp of people saying use the database, store your uploaded files in the database. Other people will say store it on the file system. And so forth. This will probably only affect folks in this room if you tackle such a thing for final projects. I would say, frankly, personally, I think the best decision is if it's really simple and quick and dirty, fine, put it in the database. But for any real projects, like leverage both technologies at what they're good at. Files belong in a file system, and data belongs in a database. So what websites like Facebook and the like probably do when you upload a photo is it stores it somewhere on some storage medium, big hard drive somewhere, and then it stores in the database what probably? The path to it or the URL of it or something like that. So that's the point here. But you can, with binary fields, upload the actual photo. But then your database starts to get really huge and bad things can happen, or just complexity. And then finally, we have some other fields that didn't really fit in the category. Enum is actually useful. If you want a field to only take on one of several values, foo or bar or baz, you can enumerate them using the enum data type. Now, you could just use varchar, to be clear, for something like that, or you could just use int if you just know it needs to be a number. But enum lets you put more constraints in the database, and per the topic last week of having this division between code and databases, or developers and DBAs, I mean, these kinds of defenses can just improve the odds of no mistakes overall. So these are good things to be able to have for free. Any questions about data types? Yeah. Uh-huh. Okay. Okay. This thing in here.
If you use that on update current time field, so if there's ever a change to that row, it'll change that, right?
Correct.
If somebody changes their password, it will
Update the field called created and put in the current time instead of the previous time. Yep, that's all.
Is there an option to do it just on the first time that it's created?
Yes, good question. Is there an option to populate the field on just the first time you insert a row? Yes. You don't use that attribute. You instead specify a default value, and in PHPMyAdmin you check this box, but there's corresponding SQL instructions to say, give this a default value of current timestamp. Current underscore timestamp is a special constant that means the current time. So yep. Yeah. Yeah, sure, we can do it right here. So we're going to call it created. Let's make it a value of timestamp. I'm not going to do, well, let's do the auto increment just to see the difference. Can't be null. It's going to have a default value, and that's it. So I'm going to go ahead and click go or save. All right, and what did it do? It did this. So alter table user. So there is this alter instruction, which you, again, could type at the command line yourself to alter an extant table. Add the field called created. It is of type timestamp. Here's the attribute, on update current timestamp, null, not null, rather. Then default is the next keyword, current timestamp, and then where to put it after pass. So, and again, and for those of you who weren't here last week, the utility of PHPMyAdmin is frankly just not having to remember syntax like this sometimes, at least certainly early on. It's just really nice to learn by doing. Any other questions? No?
You add the timestamp to the third. What happens to the data that you have created before?
Good question. So what about my existing fields? Well, they default to some equivalent of null because they were already there, so it becomes 000s for date and time in this case. Good question. But I could fix this, right? Let me just show one teaser, which we'll get more familiar with later today and also in section this week. So I could do this. Update users. What do I want to do? I want to set the created field to, let's say, 2008, 12/25, for lack of another date, at 23:59:59, the very end of Christmas that year. Set created, and that's it. So actually, because I have no predicate, I have no where clause at the end, this is going to apply to everyone. So let me zoom out and click go, and cross my fingers that I didn't make a mistake. I made a mistake. Damn it. Oh, I did. Thank you. Typo. Whew. Okay. Update. So I spelled it wrong. Okay. Affected rows, 1. Database is really fast. That really didn't take much time at all. If I now go back to browse, I should see that, yep, my created field is in fact different. Other questions? Yeah?
How does the decimal type of the database interact with the
Good question. So in the context of PHP, if we start querying data from the database to render information, which we'll do in just a bit, what it will come out as a string. Let me see if I want to retract that. That's a good question. Let me actually, during break or right after, I will try querying such a thing, and I'll dump it in at a very low level, and I'll take a look at the data type that comes back. I'm going to guess it either comes back as a string or as a float, and you just have to accept the fact that it's only of so much precision. But PHP probably uses 64 or 128-bit ints, I'm guessing, but I'd have to take a look, or floats rather. Good question. So you're pushing the limits of my familiarity because I always do it the right way. So I don't know what would happen if you tried inserting a float and therefore ran into precision issues. What we would typically recommend in the course and what I would do is when inserting into a decimal field, use a function like sprintf. Make sure you're generating a string that looks exactly like the number you want to store, and then store that string into the database so you don't risk any loss of data, which I suspect would happen if you just passed in an actual number. And here too, PHP, as we said last week, a couple weeks ago, is very loose when it comes to data type. So I would say as a rule of thumb, and not to punt, when in doubt, do it the safe way, which would often be to use strings in PHP. All right, so let's go ahead and take a look at a little teaser here. So I think we have this example among your printouts from last week. Let me go back into our source code from then. And I thought I'd try to make this a little more real world with this example. So we have, let me see if I can get it real fast. Let me pull this up. I just need to grab a URL. Come on. It's from this one. Okay, let's see if it's at the end here. There it is. Okay. So the motivation here and the teaser here is that for last year, the computer science faculty for the engineering school would gather once a week for its weekly faculty meetings, and we would order lunch. And the process for these 20-plus, very technical people was to email a staff member what they want after pulling up this URL, which got circulated every week, and you type in what you want to eat, you type in all of your exceptions, and then that staff member would write back for any clarifications. And all this silliness, very low-hanging fruit for automation for this thing. So I foolishly realized, I was the first to realize we should automate this, so I opened my mouth first. So thus was born my Friday night that year, taking this menu and converting it into a website. And I had just taken, or actually taught, CS75, and I realized, wow, for a very simple app like this, really don't need a heavy-handed solution like a database. We certainly I don't want to have to administer this thing in perpetuity. Kind of nice if I can implement this app, put it in a zip file, have someone put it on a server somewhere, and done, voila. So, and that was actually my design goal. So I just had in mind my little pizza ML thing, So in fact, the approach I took was to implement this little file. So I didn't include this file because it's actually pretty big when you print it. This was admittedly a little tedious because I decided after looking here, looking here, looking here, looking here, I didn't really want to screen scrape this whole thing because it would have taken me an hour or more just to write the screen scraper. I decided that copy-paste was the most efficient way to get this data into a XML file, much like you might have for Project 1, though you only had 3 items. I kind of get yelled at if I leave off a professor's favorite meal just because I'm lazy that night. So I manually generated this XML file. I needed some arbitrary format, so I called the root element menu. I then realized, okay, they have some standard fillings for their deli sandwich. Yeah, you could design this many different ways. Here's some cheeses, condiments, spreads, category. Okay, and here was the interesting part. So we had a few different categories, like what was the first? Entree salads. And so I just kind of typed this in. And you could have designed the XML file in a very different way, but I just needed something simple. And if we ever made changes, as happened this year, they actually removed the restaurant, a couple items from their menu. I open it up with Emacs or whatever, delete, 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 save, done, updated for the year. So it was actually compelling, and I was actually rather amused by how this sort of story we try to tell in Project 1 to motivate the real-world relevance of this was completely relevant when I had to solve this problem a couple of years later. So now I had this XML file, and I needed to actually render it as a menu. So I took a couple of approaches, and I decided simplicity was key. This is actually not the real version. I simplified for lecture, but I just wanted it to be very simple. And actually, let me see if I can show you the pretty version, lest you think my design skills entirely lacking. So this was the final version. It's pretty, I think. It's simple. You just type in your name up top. You type in any special request. You click that button after clicking one radio button, and done. So what was interesting for me was, one, we had to deal with some form submission here. And this code is available on the website. And even though we won't go through it in great detail here, you'll actually have it under your wing for or you'll have it in your toolkit for tackling Project 2, if you want to see how I handle various form submissions. And there are a few features that I wanted to be able to implement, like if you click over here and then start checking these things, I wanted clicking over here to erase those. So I'm actually using some JavaScript to really keep the interface as clean as I would like. I think I also have a little autocomplete here. Oh, not in special requests. Yeah, I have a little autocomplete. So here's all of the David faculty members. So I just had a little drop down thanks to YUI, the JavaScript library that we'll talk more about in a couple of weeks' time. So in short, it was meant to be very simple. But I didn't want a heavy-handed solution for the database. So it turns out that even though we're using MySQL, do realize that in PHP and in other languages, you have access to a SQL API, which means you can use SQL commands, select and insert and update and delete, but you don't actually need a database. You don't need a DBA. You don't need a special server. You just need the right API. And there's an API called SQLite, SQLite, and as the name implies, it's a very lightweight version of a database engine. So what this means is I'm actually storing all of people's orders for the week in a binary file in the current working directory that, thanks to some PHP code, allows me to query it with select and insert and update and all of this, but there's no database server running. You can literally move that folder to another computer, and so long as the computer supports PHP, it will still keep on working. So even though we won't use this in the course, because I think longer term it's more helpful to know sort of an actual database engine, realize that for small projects, completely viable. So this is a very simplified interface here. I have just a name field and just a submit button. I have all of these radio buttons. Let's just take a quick look at how I went about generating this. It took surprisingly little code. So this is from last week's printouts in the lunch subdirectory. And this is the development version, which is designed to be simpler. The production is the prettier one. So you're welcome to poke around with either. Let me open lunch.php, and you'll see not much code. Now, granted, not much website, but it is completely functional. So if you take a look here, most of this is XHTML, but here's the person's name. Oh, and this is inside of a form. Right now, the form is designed to submit to SQLite. .php, which is a SQLite version of the database. And what I did for edification is I implemented the same thing for the class using CSV files and using something else besides SQLite. So what else do we have here? We just have the submit button. OK. And then what do I do in this table? I laid everything out in a table just to keep it simple, even though it's invisible. And now I do a for each. I use XML because I, at the very top of the file, did this, which should look familiar. Little new simple XML element, get the contents of menu.xml, and then And now if I scroll back down here, little use of XPath. Let me zoom in. So I'm going to execute the query of an XPath for /menu, /category, and then what does this predicate indicate? Give me which category? Yes, the specialty sandwiches, because if you recall briefly, I had attributes that define the names of the categories. So here we go. Give me the category element whose name equals specialty sandwiches, then give me all of the items beneath it. This returns an array, which I can then iterate over each of the items with this syntax here. And then for each of these, I just output an input field. I output an ID purely for JavaScript reasons, realize. And then down here, I have a name element. I have a type element for radio, and then the value of this button is just going to be the actual name of the item. And that's all it took to generate this page. Now, it was a little anal when it came to the real version, which is why I added the colors and all of the prettiness. But functionally, this is the exact same thing with a smaller menu. All right, so what happens when I actually submit this thing? Well, let's take a look at SQLite.php. So again, this code you won't use in Project 2. Do use the actual database. But this is pretty much all it takes if you ever need sort of a quick and dirty implementation. At the very top, I just do a quick sanity check for the class. If the name field or the item field are not filled in, bounce the user back. Tell them to make them give us data. And then this is all it takes. And now this hints at PHP's object-oriented design, which you've seen teasers of with like the simple XML API. But notice what I first do is this. I instantiate what's called a PDO object, Portable Database Object, I think is the acronym. This is a generic library that allows you to interface not just with SQLite, but with many different libraries. So I'm saying give me an object of PDO, give me use the SQLite API, and use the file called orders.db, which is a binary file in the current working directory. Then from the documentation, I realized I had to set this attribute for attribute error mode and exception. I just did it as I was told, frankly, the very first time I played with this. Now I prepared the fields. So thankfully, this API does not use MySQL real escape string. It actually uses the quote function, which is synonymous with escape. So I just call that, passing in the field. And then I call this exec function. So the exec function says, takes a SQL string, insert into orders, a name and an item, and then values with just those two fields. And that's it. If I had some problems, if I trigger an exception, I yell at the user with that. But then if I scroll down here, I simply tell the user one something or other coming right up. So let me go ahead and try this. So I am David. I'll order Mediterranean chicken. Submit order. Now a simple little message, but what's been stored now in that database, the .db file, which you can see right here, there is my orders.db. I have now a little database containing that. So if I now implemented a staff version of the page, which I did for the real version, I could just execute select star from orders, and then I would see everything that was actually stored there. So what's really neat about this PDO library, even though we'll offer it really just for an FYI for now, is that if I decided that, man, everybody's coming to lunch now that it's so easy, I really need a real database. What's nice about this abstraction library called PDO, which again is a PHP thing, is I could just change the string SQLite orders.db and type in essentially the name of a MySQL database. And so long as I created the right tables on the database, same exact code, I could use a completely new database. And this is what's compelling about a lot of database libraries out there. If you're working in a company where you suspect that for whatever reasons, religious or technical, that you might have to change databases down the road, you don't need to use these MySQL-specific functions. You can take sort of a higher level approach, implement it more generically with an API, and then change a configuration file. So realize this opportunity exists. Yeah? No, I think for if you're if you're coming to the course with more experience and want to learn this, by all means, that's great. But I think because the problem set covers so much new stuff for most people, I would encourage most people to use the MySQL functions, which even I myself tend to use when I know I'm never going to change database engines because it's just so easy, or so relatively easy. So we leave it to you to decide. Yeah.
So in that video in the call, the new video, I feel like throwing order. Is that the same as making the connection to the database? Is that what you replace?
It is.
Replace that whole section of code?
Yep, instead of MySQL connect, you use this line here. But realize this is a very different approach. So notice this exec function also takes the place of the MySQL _query function. So the takeaway is that for all of the lecture examples I've done thus far, if we decide next year to teach Oracle just because, I would have to rewrite almost all of my lecture examples. So minorly annoying, especially annoying in real production environments like actual companies. So the motivation for going a route like this is to actually make it easier down the road to change databases if you need to. But the probability of that, frankly, for most entities is probably relatively low if you're changing database engines entirely. Better to make the right decision up front if you can.
So does the local data run support something like MySQL?
Yes. Yep. You just plug in a different string. Instead of SQLite, you say MySQL and then some configuration options. So it's a powerful thing. And there exist others. There's a PEAR, P-E-A-R, which does the same thing. And I'm sure there's third parties as well. Yeah. Yeah, PDO comes with PHP 5 point something. You do have to sometimes install it manually. I think it's newer. Frankly, I've used PEAR, and I thought its documentation was horrific, and I just could never wrap my mind around a lot of it, so I abandoned it. And to this day, I still use the MySQL one usually if I know I'm not going to move away from MySQL. Most of my projects, have a shelf life of 2, 3, 4 years, not 10 or 20, so it doesn't really matter if I commit to one or the other. Question? Yeah.
So does PDO enforce a standard SQL API, or do you have to watch out for that? Proprietary stuff?
Yeah, it's a good question. It does not enforce constraints, so there are some instructions, some capitalized commands, if you will, that will work on some database engines, but not all. It's not going to notice and try to filter those, so you have to just be careful yourself about not using certain database-specific features, which are relatively few, and odds are in the class you won't trip over such things. But when you start to really dive into the depths of SQL, you can run into that. Another question? No? Okay, let's take a 5-minute break here to change tapes, and we'll start with you. All right, so we just inserted this lunch order into a faux SQL database, or a SQLite database, using this insert instruction. So just to round out our menu of options, what I thought I'd do, even though we don't use this for the actual lunch site, go ahead and zoom in a little better here. Let me go ahead and open, let's say, the CSV version of this. So if I change the action line of that piece of code to go not to SQLite.php, but instead CSV.php, the destination would be this fairly short file. So the response, let's fast forward to the ending, in XHTML is just going to be this, one something or other coming right up. So aesthetically, the result is the same, but just for the sake of options, I decided, how would I implement this same project using CSV? Because frankly, after this class, whipping up something quick and dirty like this, also very reasonable. So I can do a little sanity check at the top of the file. Did they actually provide the form fields that I wanted? Then I do the following, and this is literally something you can tuck away perhaps for some random project in the future. Let me go ahead and open a file called orders.csv. I'm going to open it in append mode. Quote unquote A means concatenate onto the bottom of this file the following data. So this means I won't override past orders. And now I use what's called a file lock. So you run this danger anytime you're using the file system yourself, that what if two faculty members try from separate computers to write to the file simultaneously? Really weird things could happen. For instance, half of the first few letters of one of their orders might end up in the file, then the first few letters of the other person's order, then more of their. Just weird things can happen if you try to write to the same file simultaneously. Or maybe even worse, only one order gets through. You completely clobber the other person's order just because, by low probability, they ordered lunch at the same time. And it might not even be that low probability, right? If this staff member emails out the faculty at a few days before lunch, says, get in your lunch orders, as happens in reality, there's a lot of us who check email compulsively. We might very well click that link simultaneously and start to do it ourselves. So important detail. So this line here means get me a file lock of type exclusive. So lock underscore exe is a PHP constant that says get me an exclusive lock here. And then what do? Now that I have an exclusive lock, I can go about doing what I want to do without fear that someone else is going to try touching the file. At this point, if there's another thread running, another user trying to access my website, they're going to see the little spinning globe or whatnot. Now, for a brief second, this isn't going to take that long, but they will be stalled, so to speak, while my code locks this file. All right, what am I going to do? Well, I want to first put the item's name and the person's name in an array. And I'm doing this just because I want to take advantage of a function from PHP called fputcsv, which takes an array as one of its arguments, takes a file handle as its other argument, and writes the former to the latter. I actually swapped the order of those variables, but the same idea. And what's nice about fput.csv is that it handles the quoting of strings, the insertion of commas. So if you're familiar with CSV, comma-separated values, as we saw last week, actually, when I grabbed a little stock quote, you just separate the fields with commas. But how then could you do something like a name of David Malin, comma, Jr.? Right? You don't want junior to be conflated as a second field in the file. You want that to be part of the first. So what things that fput.csv does for you is it quotes the whole thing properly, and you just don't have to deal with those kinds of issues. So it's a nice function, and that's why I took the extra step packaging my stuff in an array so I could outsource the hard part to that guy. Then fclose. This releases the lock, closes the file. So voila, I'll now have a file called orders.csv, which might look a little something like this. David and David J. Malin all ordered something like this in past time. All right. Well, finally, what about XML? Project 1 had you manipulate a whole lot of XML, but you never actually wrote any XML. So how might we do this as well? Well, unfortunately, it's not as clean as would be nice. You can't just append to an XML file. For what reason? Yeah, it's in order, but specifically, what's the problem? The root element, right? That damn close tag really gets in the way of what's otherwise a very simple process. So frankly, this is one of the downsides of using XML, at least for an application like this, because I'm actually going to have to load the whole XML into memory, into a DOM. I'm going to have to insert my additional item element, my additional node, and then reserialize it, convert it back to a big string to disk. So there's actually some more steps involved. But maybe it's a little cleaner. CSV is a little limited. It's just a table. It's just rows and columns. You know, XML gives me objects and random associations between data, so that might appeal. So what do I do here? Again, a little sanity check at the top of the file. Here I'm opening my file for both reading and writing. R+ is the nomenclature there. I think RW might work, but I know R+ does work. I do acquire a file lock, because I don't want anyone else to screw this up. Yep.
Someone handling queuing for the lock.
Someone handling queuing for which?
In other words, if you go in, you're making an order, I come in, do I just blow up, or do I wait for that?
No, you will stall for some number of milliseconds or seconds, as long as PHP and the operating system deem appropriate.
So somebody's handling queuing.
Yep, no, that's what you get with the locking API in PHP. And there's some caveats. Just realize if you read the documentation, this, I think, does not work on Windows platforms, and it also does not work on NFS platforms either. So that might actually limit your usage, but maybe not. So read the fine print whenever trusting something like this. But again, if red flags are now going up, ooh, can't use this here, can't use this there, well, there exist actual databases which address this problem too, hence MySQL. All right, so how do I get the file into memory? Well, I'm going to use fread. Actually, why did I do this? File size, fread. I didn't really need to do this. I don't know why I did this. I could have just done file get contents. Oh, no. This is why I did this. So I do need to do this. Because I want to implement a file lock, I can't use file get contents, because that very nice function grabs the contents but doesn't acquire a lock for me. So I have to do it sort of the old-fashioned approach. I grab my file lock, just as I did last time, but now I use the lower-level fread function, which takes two arguments. One, the name of the file pointer that you want to read from, and then the number of bytes you want to read. So I'm using the file size function there. So this approach now reads the file into memory, but I'm hanging on to the lock. No one else can touch this file at the moment, so that's good. Now I build my DOM using this call from like Project 1. And here's the slightly annoying lines of code to actually add a child. I go to the root element, which is going to be the orders element, as we'll see. The end game is to produce a file like this. It's not pretty printed, but if you take a second to read that, we have an orders element, and then an order child, which has a name and an item child each. And then it repeats multiple order elements. Okay, so what do I want to do? I just want to add an order element. So I add a child to the root of this thing called order. I then add a child to that called name. I add another child called name here. Then finally, what do? I rewind to the start of the file because I have my lock still. I then do an fwrite, printing this DOM as XML. This is a function with the simple XML API. It changes your DOM into an actual XML string. I close my file. Done. So more steps, minorly annoying, but at least it's XML content, which means now maybe for the viewing system, the front end for the staff member, now I can do XPath on it, and I can use my familiar XML function. So trade-offs, some good sides and some bad sides to this approach. Any questions, though? No? Okay, so all of that is available in last week's source directory. And actually, I was a little disappointed to realize that there was not only this, there's also a whole other web page full of salads. So I was a little disheartened when I got through this part of it. Anyhow, okay. So more sophisticated database techniques that will serve us well for Project 2 in particular. So one, quick note that there are some functions besides AES and crypt. Just wanted to at least draw your attention to the types of functions, frankly, that are maybe the most helpful. Date format is very commonly used, and time format. So PHP has its own functions to do things like this, but if you read up on the documentation for these latter two functions, you can actually tell PHP to read from a timestamp field, or read from a date or time or a date time field, and you don't have to get it back in this very generic year, hyphen, month, hyphen, date, and so forth format. You can have it massage that into most any human-friendly format, and you do it by passing in a special format string, a la printf or sprintf. So just check the docs for a feature like that if you'd like. But here's the more interesting tale. So the downside of a relational database, or just equivalently using Excel worksheets to represent all of your data, is that you often want to be able to relate data from one table to another. Now, what do we mean by this? Well, remember the very simple example that we started last week with. If you've got an address book, then you want to implement this as a website for yourself, a la Gmail or any website like that, you need a person's name, phone number, and then what were the worrisome fields? What did we realize? Zip code, city, state, because those immediately become very redundant. I don't need to store Cambridge, Massachusetts for all 1,000 residents of Cambridge, Massachusetts. Probably just need to store 02138, because then I can have a separate table that has a column for zip code, city, and state. And I just mentioned Cambridge, Mass. Just once in that table. And what do I put in the table for my addresses? Just the zip code, right? So this is the idea of normalization, where you factor out common data, put it into separate tables, which is so nice and clean, feels really good and healthy at the end when you've actually kept your data nice and distinct and normalized in this way. But it's kind of a pain when you then need to merge it back together. So SQL supports what's called a join, which, as the word implies, allows you to join two tables, and you do this by linking them by way of a common field. So this relates also to last week's discussion of indexes and primary keys, which we'll see again here. So here's an example. So these two tables here capture the notion of an employee in the employees table at the top, and then an orders table. So you can think of the context here, and this is borrowed from one of the recommended resources on the course's website. This is w3schools.com. So the context here is we have an employees table, and the internal company accountants and whatnot, they want to keep track of who ordered what office supplies belong to which people. So we could imagine have an orders table, like the one here, that lists the product ID that was bought and the product name that was bought, and then the name of the employee. But you're going to start to see lots of inefficiencies, right? If one of these persons, like Stephen, is really greedy and buys a lot of office supplies, we're going to see Svensson Stephen in every row of the orders table for every little product he bought. Now, that's not that bad, right? And odds are there's not another employee with that same name. But what is inefficient about that particular redundancy? Sorry? So the space, the storage space, right? Why can't we boil down greedy Stephen into like a 32-bit int, right? And store just 4 bytes per order from this guy instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 bytes, so maybe 18. So like we can use 1/4 the storage space to keep track of Stephen just by using his employee ID instead of his name. But the challenge then arises when I want to figure out who ordered the printer. Like, really not useful to tell me, the staff member, oh, it was employee number 1. Now go look up him. It'd be a lot nicer to answer these queries with the information we care about. So we want to take the table called employees, we want to take the table called orders, and we want to join them in such a way that the employee ID fields line up so that what we literally get is a new table, a temporary table, if you will, that has all the fields we care about. And this is by way of a feature called join. One approach to this is with the following syntax. So select employees.name. So you can specify, though we've not done it thus far, the name of a table dot field name. For all the more clarity, really important when you're actually talking about two tables, because otherwise it could be ambiguous, especially if the fields are identically named. So I want to select employees.name, comma, orders.product from two different tables, employees and orders. So the syntax there is employees, comma, orders. That's all. Where, and now how do I want to do the join? This is what's called an implicit join, because we're not actually saying join. We're kind of implying by way of this last predicate how to do it, where employees.employeeID equals orders.employeeID. So that's doing this. This visual here of coupling the two tables based on this shared field is what's being achieved by that last line there. So what you get back, if we actually had these tables in memory, we would get back a temporary table, a result set in PHP speak or in database speak that has 3 rows, 2 columns. The first column is name, because I specified employees.name. The second column is called product, because I secondarily said orders.product. And then listed in there are just the 2 fields I asked for, namely the names and the printer. But the coupling has been done correctly. If we do a little sanity check, yep, who ordered the table and the chair? Well, that was employee 03 and 03. Yep, that's Stephen. Who ordered the printer? Well, that was number 1. That was Ola. So in fact, it worked. So this is one way of keeping your data nice and clean, no redundancies, which just wastes space and also can lend itself to getting out of date, right? If you have multiple copies of Cambridge, Mass. 02138 around, and for instance, they do some redistricting or something like that, I mean, stupid things like that can happen where now you have to worry about updating your data everywhere. It's just not a good principle in general. So there's another way to do this too. And I frankly think the latter is a little more clear. It's how I tend to write my code. So same exact result, same exact problem, different syntax. Select employees.name and orders.product from employees, join the other table name. So I like this because it explicitly is telling me what I'm joining to what. So I'm joining employees with orders. Employees join orders. What am I joining these two things on? Well, I'm very explicitly saying, and join them on employees.employeeID equals orders.employeeID. So the end result is exactly the same. If unfamiliar with SQL, I personally like this because it makes ever so clear what's going on. And this syntax here also lets you do joins on multiple tables at once, which for more complex scenarios is quite useful to be able to join together and get back one big table. Yeah? Mm-hmm. So this would be an explicit join, or this would also be known as inner join. So there's several different types of joins, which we won't quite tease apart yet. Inner join, outer join, left join, right join. Implicit is kind of my own nomenclature because it's a join, but it's not really labeled. But this would be an inner join because we're joining two tables visually like this. Yeah?
Now, this is implemented in MySQL. So is there any MySQL database?
Joins, yes. This syntax. Pretty much everything we teach in the class is common across all databases. Yep. So we have no bias for syntax, really. Other questions? All right. So a little discussion about milk. So this is where database design actually gets, I think, fun, but also hard. So the story I was told when learning a little bit about this topic was literally this example. The operating systems professor I had told us this story. So you've got a roommate in college, freshman roommate or whatever, and you've got a little dorm fridge in your dormitory room, and one of you comes home and discovers you're out of milk, of all things. So you decide to close the refrigerator door after discovering this. You walk across the street to CVS, and you get in line to buy some milk. Meanwhile, roommate comes home, opens the fridge, realizes, damn, we're out of milk, better go get some milk. He or she closes the fridge, walks across the street to some other store, and then long story short, you both arrive and feel kind of stupid because now you have what? 2 bottles of milk, and milk goes bad, so clearly this is a big problem because now you have too much milk. So silly though that example is, how could you have solved it in the real world with that freshman roommate? Okay, so that's pretty good. Leave a note. It's like, gone for milk, or don't buy milk, I will go get some. What else could you do? You could give him a call. Okay, so that's actually not bad. That analogy works too. A little inter-process communication, sure. A little message sending, event handling, sure. Right, realistically in college, what's probably going to happen? Like, nobody goes for the milk, right? So you could just abort, which, actually happens too sometimes. Thread contention, just quit, let the other guy win. So lock, and I'll take this answer just because it's the one I'd really like to go with, but it's the same idea as the notes. So you need to somehow inform the other thread, the other CPU entity, that don't do what you're about to do. So a note probably suffices. A more draconian approach would be to put a padlock or something on the refrigerator. Then you, the first roommate, after locking the fridge, go across the street. Now your roommate is literally there stalled, like trying to get into the fridge, right? This is what would happen in the computer, till finally you come back, put the milk in, remove the lock. He or she then opens the fridge. What did they realize? There's milk, so they don't evaluate to true just as you did. They evaluate to false. We don't need milk, and there's no problem now. So what is the relevance, my God, to what we've been talking about here? Well, anytime you need to update two tables at once, you run into this problem. In fact, with CS75 Finance, one of the features that's expected is to implement the value of someone's portfolio. So you've got a users table or something like that, as you'll soon discover, if not already, and you're going to need to keep track of how much cash a user has. But because you want users to be able to buy an arbitrary number of stocks, you can't really have another field for the stock symbol that they own, because if you just put in the users table, stock symbol, that means they could only buy one share of stock or one type of stock. So you might think, all right, well, let me put two columns then, stock 1 and stock 2. Now the users can buy 0 to 2 different types of stock. Well, that's kind of limiting too, so you have a third column, a fourth column. Around now, this should start rubbing you the wrong way, this design approach, right? Because now, if you want to let the user have, there's the S&P 500, feels like I need at least 500 columns so that the user could buy any one of those 500 stocks. But there's not even just the S&P 500, there's other stocks out there too. So very quickly can you do really a lot of damage. So if you want a sanity check, frankly, for the course, or in general, if you're scrolling to the right, you probably have too many columns. So I can't even simulate it because it would take too long. So there's hopefully a solution here. And this is what a good table design or schema design is all about. Instead of having just a users table with everything, so here's going to be my users table for project 2, or really anything like it. I'm going to have like a user name. I'm going to have a password. And I'm going to have cash. So it feels like I need at least these fields. But now, and we'll call this the users table, feels like I should factor out the stock stuff. And this is exactly the principle implemented in, by relational databases, table-based databases. We might have like a portfolio table. You can call it whatever you want. And in here, I'm going to need something like, and this will be version 1, we'll improve, username, and then maybe symbol. And then what else do I probably need for this so-called portfolio table? Sorry? Okay, so price. So possibly price, but more importantly first? So number of shares. So we'll call this quantity. So this alone, and I'm pushing back, we don't really need price here because we can query that on demand and compute mathematically their portfolio by multiplying current price times quantity plus cash. Okay, so we could do this. And now I say this is version 1 because if we really want to be diligent, what's inefficient about this design already? Yep. Yeah, username, right? Especially if you're using email addresses for the website. It's just a lot of characters. So you know what? Let me change this. Let me not store username. Let me store a more efficiently represented piece of data, UID. And now let's give everyone a UID over here. And this is just an int from 1 on up to 4 billion. Hopefully we won't have more users than that. And now we have the ability to have pretty much the same design as these guys did for orders and employees. We can still resurrect some data by joining these two on their common fields, and we can search one based on data in the other. So already we're actually in a pretty happy place here. So let me actually mimic this in a little table design here. So let me go ahead and go back to my database, fall 2009. Let me go ahead and log back in here. All right, so let me go ahead and create a new table on database, Malin Fall 2009. I'm going to call this, let's just butcher my current one here. So let's see. Structure, I currently have this. I'm going to get rid of my created field just so we make a picture that's consistent here. I'm going to click yes when asked to sanity check it. So I've got username. Okay, so let's change a few things. I'm going to click the pencil. I'm going to be anal and just change this to username. So literally make the picture. Now I've just clicked Save. So now we're almost there. I have to add 2 other fields. Where they go doesn't matter. I tend to be a little anal, and most people tend to put like the user ID field first in the table. It's just by a matter of convention, username too, and less interesting data after it. So let's be a little anal here. At the beginning of the table, add 1 field, and I'm going to call this field UID. I'm going to make it a, UID. I'm going to make it an int from the drop down here. This is not an important detail. Length/values for ints, this is kind of a legacy thing. You specify the width of the number aesthetically. So when you used to use the command line environment for MySQL, you get those ASCII art tables. By saying 10 here, it would reserve 10 white spaces for the number. For real design, this really doesn't matter, but it wants a number here. So that's pretty much the only implication. It doesn't mean you can only have 10-digit values. It doesn't bound the size of the data type. That is still a 32-bit int. All right, what else do I want to do? I'm going to make this unsigned. As a matter of convention and good practice, unique IDs should be non-negative numbers. Default doesn't matter here because I'm going to do this extra, auto increment. And now I'm going to define this as what's called a primary key. So if you know in advance that this is going to be the field that uniquely identifies every row in the table, make it a primary key for a couple of reasons. One, it's for efficiency's sake. The database will leverage this and realize, oh, this is a really important field. Let me build up a fancy tree structure in memory so that I can search really quickly on this field and so that I can join on this field more efficiently. So that's a good thing. If you know of something about a field, tell the database. With the exception that it can cost you space sometimes. So more on that in a bit, perhaps. All right, username. Let's put, incorrect. Must be defined as a key. Oh, do we already have username as a key? I think we might. All right, so I'm going to go back here, a little sanity check, structure. Oh, yes, so we already have username as a primary key. I can't have 2 primary keys, so I'm going to go ahead and drop this primary key. A little sanity check. Okay, now I'm going to go back and unfortunately redo that little line there. So now, UID, it's going to be an int, size 10, which is the convention there. Attributes, unsigned, not null, auto increment, primary key, save. Cross your finger. Damn it! 1 auto key. All right. I'd rather not deal with this right now, so we're just going to blow away the whole table. So, users. When in doubt, start over, especially when under pressure. All right, UID. Oh, look. This was cleaner anyway. Now we can do them all at once. All right, now we have username. What do you want this to be? Varchar, don't really know, so let's go with 255, but you could argue this anyways, maybe 64. No one's going to type 255 characters anyway, but whatever. Password, we'll keep it simple. What did I call it? Pass over there. Oh, and realize there is a reason I call it pass sometimes instead of password. If you call it password, MySQL could conflate it with the function called password, and you can avoid that by using backticks everywhere, as I said last week. But if you can avoid using a reserved word like password or a special word like password, you might as well. All right, varchar, we're just going to keep this simple, no crypto this time. And then cache. What about my cache data type? Who feels the strongest? Speak louder. I like decimal. So float, dangerous, if you want the Superman 3 effect. So let's go with decimal. And then if I can remember the syntax for this, 5, 2. Let's see if it rejects this or not. So 5, 2 I think means 5 digits to the left and 2 digits to the right, which is fine. Well, that's not, which is fine because I don't want to use, well, we got to pick something. Well, maybe you can just do 2. I actually don't recall. That's a lot of money. That's enough. All right. So now attributes. Unsigned for my UID. This guy, this is a varchar, so let's scroll over here. None of these is null. How much by default? Well, we're going to do a little promotion a la online banks. Everyone's going to get $100 when they sign up, so I'm going to give that a default value of 100. I'm going to make UID a primary field, but I'm also going to make username a unique field because I don't want multiple people registering with the same username twice or the same email address. So the distinction here is really a matter of principle, but there's also some other implications. So by saying you can only have one primary key by definition of what a primary key is. A unique field behaves very similarly. You're telling the database this is also going to be unique, so optimize accordingly. So it allows you to have, this is another index. This is a unique index as opposed to a primary index. But the behavior is ultimately the same. I'm going to cross my finger. Oh, storage engine. For now, I'm going to leave it at my ISAM, but a word on InnoDB in just a bit. I'm going to go ahead and click Save. Phew, worked. I can now learn from the example. So that's the syntax that was outputted there. Did I not have the auto increment on? Did I miss that? I did miss that. That's not a problem. I'm going to click the pencil and go over to the extra and click auto increment. And now click Save. And now we're good. Okay, so now let's just watch. So if I click Browse, there's no one in there. Now suppose I manually register. Someone calls me on the phone. They really want into my promotion. So I say, fine, you don't have to use the website. So I'm going to skip the UID. I'm going to say, this is J Harvard. Sir, your password's going to be Crimson. Totally bad practice. But here's the default value. I'm leaving this blank. But when I click Go, notice that it gets inserted. This is the SQL that's been executed. Fairly familiar syntax now. We've done that a few times. But now if I browse, notice that we do in fact have John in our database, and his values are as we expected. And his user ID is automatically signed as 1. So that's a nice feature we get for free. Even if two people try to register simultaneously, the increment will happen properly. All right, so what's the relevance here then? Well, this scenario that we began to replicate a moment ago lends itself to what are called race conditions. So a race condition happens when you might have two threads contending for access to the same piece of data at the same time. And what's bad about race conditions is that if one changes that value, the other thread might not realize it. Case in point, the silly milk example. So where might that happen here? Well, I'm writing some PHP code that allows the user to buy some shares of stock. So I want to buy a share of Google stock, which costs like what, $300, $400, something dollars. So my code, just thinking aloud here, has got to check how much cash David Malin has in his portfolio. Okay, he's got $10,000 right now. So that's enough. $10,000 greater than $400 for one share. So I get back true there. Then I turn my attention over to this table, and I do an insert. Insert into here the symbol GOOG, 1 for quantity, and user ID, I plug in David Malin's user ID, whatever that is, and then I go ahead and decrement the cash here by $400. So now he's got $9,600 left. So unfortunately, I had, it took a while just to say that, but if I don't have a padlock on the fridge, what could have happened in this situation? Cash might be the same value in what sense? Yeah, so there's this window of opportunity where I as a thread, I can only do one thing at once. I as a PHP script can only do one thing at once. I can update this table or I can update this one, but I can't kind of update them both simultaneously, at least not yet. So what might happen? Well, a malicious David Malin might actually has, as he has at home, 2 computers open simultaneously. He fills out the appropriate forms to buy a share of Goo and then clicks Go simultaneously on both computers. And what happens? Well, one thread, one web server thread that's handling computer A's request, and there's another handling B. So A checks this table and says, oh, David has $10,000. But just by the way operating systems work, the OS, Windows or Linux, decides, you have had enough CPU time, I'm going to suspend you ever so briefly. Thread B now gets some action. So thread B checks the table, realizes, oh, David Malin's got 10,000 cash. Ah, damn, it's my turn to sleep. B goes to sleep. A is woken up by the operating system. What does A do next? Buys the share over here, and he does the insertion. Now what happens? He maybe gets slept. So many different things can happen now. So maybe now B also does the insertion. But if B checked, not that David has enough money, but checked how much money he has, it came back as 10,000. If the thread stored that in a variable and then did 10,000 minus 400 equals 9,600 and then did an update of this table and said update, set it cash equal to 9,600, what did David Malin just walk away with? Like 2 shares of Google stock instead of just 1, because he didn't lock the refrigerator before actually modifying these tables. So this is a problem when your operations are not atomic. That's the buzzword here. Atomic means it all happens at once or together or not at all. So these operations are not atomic because stuff can happen in between my looking at and touching this table and my looking at and touching this table. So it's kind of as though I, the database designer and the developer, just want to say, whenever someone wants to change my database, like hands off to the rest of the world. But this is kind of a bad approach if your whole point of making this website is to scale. Right? It's not such a good thing if you have to, hold back all dozens or hundreds or thousands of users just so one person can update your database. Hopefully there's a better way, and there are, but this most dramatic approach for fixing this is to grab a lock, not on the file, as we did earlier with CSV files and XML, but on the tables. So that database engine, that database storage engine called MyISAM does not support what are called transactions, more on that in a second, but it does support locks, where you can say, lock this whole table, they're mine until I'm finished updating them. And that will solve that problem, but it will also block anyone else who's trying to write to the database simultaneously, which might just stink for performance reasons and for scalability reasons. But there's another approach too. You can also insert and update a field all at once. And this can be used to solve different problems too. So what you can do here, and actually, let me come back to this, because this actually solves a slightly different problem. So in MyISAM, the database engine we've just kind of been using by default, but also because it's generally considered the highest performing storage engine, you can do this. You can execute a line of SQL, either by pasting it into phpMyAdmin, which you're never going to do in reality, or you can just put it inside of a string to MySQL query in PHP. You can say lock tables account. Account is the table in question in this example, right. So lock the table called account right. If we want to apply it here, lock the table called users. Okay. Line 2, I'm going to go ahead and select the balance from someone's account where the account number equals 2. So again, different example, but same idea. The context that I prefabbed here is bank accounts. All right, so, and actually, this is actually the example from MySQL's own website when they discuss this. So, select the balance. What do I next want to do? Well, now go ahead and update the other table called account, or rather, go ahead and update the table, setting the account balance equal to 1,500, where that user's account number is 2. So in other words, the problem here, the risk in this situation, is that I'm doing a select, much like the roommate opened the fridge to check. Then I'm doing something else. And you don't want anything to interrupt these two statements because the second one, the update, depends on the first one. Number equals 2. Well, okay. So I apologize I think I made this slightly misleading here since I just pasted them somewhat out of context. So we lock the tables because the context of this problem is that we're selecting the balance because we want to check it. So we're going to perform some kind of arithmetic or whatnot on the return value of that statement. Then I ultimately want to update the account balance, and I don't want anything to update those two lines of code. So I actually don't like this example now that I reasoned through it in my mind here. But let's say the takeaway here is this is how you can operate on a table and lock it and ensure that only the stuff between lock and unlock happen without interruption. So this is a very heavy-handed approach because it means no one else can write to the account table, or if I applied it here and locked both of them simultaneously, no one could lock, no one else could touch this table. So thankfully, there's another database storage engine called InnoDB. It tends to have some pluses and minuses, and you can read up on these online. Some of it really depends on how you want to use the database. But what you can do here with InnoDB is you have what are called transactions, which means you can alter individual rows without locking the whole table. You can just lock individual rows. This is a huge win because this means I can just lock David Malin's rows, but any other users can keep having transactions on this website, which is a huge plus over saying no one else can touch this database on the website. So how do I do this? Well, I say I don't say lock, I say start transaction. I then do something like update accounts at the balance equal to balance minus 1,000, where the user account's number is 2. And now I update the other user account number 1, and give them 1,000. So the example here, though it's wrapping a little bit, is to take $1,000 from one customer, put it into the account of the other, and we want this too to happen without interruption so that there's no potential for inconsistency here. The upside of this approach is that if I determine somewhere along the way that I've changed my mind or I don't want to complete this transaction because I suddenly realized, wait a minute, that person doesn't have this much money. What's nice about transactions is you don't have to run the commit statement at the very end. You can instead run the rollback command, which means any of the SQL statements I just executed over the past several seconds or so, you can reverse their effects entirely. It's like the undo of database commands. So realize this is somewhat out of context, line by line by line here, because you would instead execute these probably with MySQL query using several different lines of PHP code. But the upside of rollback is that you can guarantee that all of these lines will be executed if you're comfortable with them, or not at all, because you can bail at the very end by executing rollback instead of commit. So now this third option to handling this problem of atomic operations is this command, which this is actually MySQL specific, but it's wonderfully useful, so I'll offer it anyway. So insert into table 3 different fields with those 3 different values, but if you encounter a duplicate value, you can update that field all at once. So this is really useful if you want to say, let's say, okay, so for the Harvard news site, for instance, that I keep alluding to, because I actually use this syntax there. Once in a while, I query all of these RSS feeds, and I grab their articles, and just sometimes retractions are published, or typos are fixed, things like this. So sometimes the article's contents change, but rarely do the titles change, or rarely do like the unique identifiers for the articles. So what I do is I want to be able to iterate over an RSS feed, and I just kind of want to blindly be able to insert all of its items, all of its articles into my database. And I don't want to have to check if this article is in database, then do an update, else do an insert. So it's minorly annoying, and again, there are situations in which having those 2 different statements means they can get interrupted, and bad things can happen, a la this theft of money, even though this is a very different context. So this statement here is really nice because it allows you to insert a row into a database, but if the database detects a collision, it will just update that row with some additional data. So I use this for the news site, whereby I try to do an insert of an article and its description and its URL, but if there's been something changed, the publication date or typo's been fixed, I specify, just as we're updating the value C here, I specify update the pub date field, update the description field, but keep the title alone and keep the URL alone. So in short, this syntax, insert into on duplicate key update, allows you to either insert or update an existing field, and the database detects for you whether or not there's a matching row already. Now, what does it mean to be a matching row? Well, recall that we've defined these things called indexes. So we have 2 in this case of the users table. What this means, if I've declared UID as a primary key, and I've also declared username as a unique key, if I try to insert another row with a number of 1 for UID or a username of J Harvard, I will get an error back. But using that other syntax, I can still get away with updating a field, like changing J Harvard's password or simultaneously registering him, in this case, all in one fell swoop. So this will perhaps become a little more clear, one of these 3 approaches as you dive into Project 2, but realize that there are problems for this multiple purchases of milk and this locking problem in general. So what lies ahead? So in CS75 Finance, we have you implement first a login mechanism. Now, thankfully, you have 8 different examples of login mechanisms. So implementing that part actually should just be a very relatively simple way of just getting comfortable with some code we saw last week in this. And you're essentially going to want to have a website that allows the user to log in, tells them if they're logged in, but that's it. And frankly, we already have that in the form of code. So that'll get you started with a general framework. And Sid will start talking more about this in section as well. Then you need a registration feature. So it's not really ideal if users have to tell you to register them manually with phpMyAdmin. This is a wonderful tool for bootstrapping the project. Create some dummy usernames and passwords before you even have a registration feature. But how are you going to implement registration? Well, you're probably going to have a file like register.php, much like froshims.php last week, or froshims, the intramural sports registration from a week ago. So you're going to have to ask the user for their username and their password. They're going to click submit. You're going to have to validate some of that data. And if it's all good, you're going to do an insert with MySQL query. If not, you're going to yell at them, just like we did last week as well. Once they've registered, you can just log them in or review the spec for what's required. But that's a good thing once they've got a username and password in the database. They can then start logging in and logging out. So get quotes is kind of an interesting feature. And you'll find that the reason I've enumerated them this way and the reason they're enumerated with just checkboxes in the spec, you can really approach this project byte by byte. So project 1 was more of a big picture design problem. Wasn't as clear what you can bite off which. I mean, you can think of each of these bullets here as being 1 or 2 PHP files that either work solo or in conjunction with each other. So you really have some nice modularity here. How do I implement get quotes? Well, I could have a quotes.php file. When I visit this link, once I'm logged in, probably have a little text field that asks me for a stock symbol. I let the user type in GOOG or something like that. They click submit. And what do? That should submit either to itself, quote.php, or maybe we'll keep it simple, quote2.php or process.php, whatever you want to do. What should that receiving PHP file do, probably, given GOOG? Perfect. So we know from last week that Yahoo Finance has that download link for CSV. You can very easily copy and paste that URL into your code and then just swap in a variable name for the value of, S for the symbol name. So you can very easily dynamically generate a URL. You can use the PHP function file getContents, which despite the name can actually fetch URLs. That will return to you what type of file? A CSV file. You can use fgetCSV to iterate over the lines in the file, and you'll just get back an array every time you query it, but you'll just get back one row, in fact. So it's relatively simple. Once you've got the price, you can then just say, oh, Google currently costs $400 or whatever. So it's a relatively simple interface. Now you'll need to do a little sanity checking. If the user types in foo and hits enter, you can still query Yahoo, because you won't have a database yourself of all valid stock symbols. Just ask Yahoo. And if they return a valid row with some price information, it's a valid stock symbol. If not, you'll get back some bogus data, which you can detect, play around with that. So that, too, is fairly bite-sized. Well, now you have to implement selling and buying. And I very intentionally propose that you implement selling first, because I think it's a little easier. So I would fake buying by just using phpMyAdmin at first. You'll probably want a table structure similar in spirit to what we sketched out on the board here. So how do you buy stocks on behalf of a user? Well, make sure they're registered. Figure out what their user ID is, 1 or 2 or whatever, and just manually input some rows here for phpMyAdmin to give me as many shares as I want for Google. Because what you can then do is enable me to sell those stocks. And actually, I should add one bullet here, which is the overarching purpose of this, which is a portfolio page, which you can do at the end, you can do at the beginning. But the portfolio page, as I did verbally, is going to add up all of this. It's going to get the price of these stocks. It's going to multiply them together and add the cash. And voila, you have some kind of table format. And you can play with our own example to see what we mean by a portfolio. It's just some simple arithmetic of those values. So how do you implement sell? We leave this to you, the design. It can be checkboxes, radio buttons, hyperlinks, whatever. But you're going to want a user to be able to buy, to sell all the shares of their stock at once. We decided to keep it simple. You don't have to sell some fractional shares or anything like this. You liquidate all at once for a given stock. So you can actually do that with a hyperlink. It can be something like sell.php ? S equals whatever, because then you can have a file called sell.php that receives that symbol and does what? Probably a delete here, but you're probably going to want to do what after deleting their share? You better give them some cash, otherwise it kind of defeats the whole point of having sold it. So there is some commingling there, or some relationship between the two tables. And then finally buying. And it's in buying that you'll really run this risk of losing money for yourself, for the E-Trade-like site. Right, if you sell stocks and don't give anyone some cash, that's actually not such a big deal for E-Trade, right? They kind of make out okay. So that's a problem, but it's not as bad a problem with buy. So take particular care with the buy feature so that you don't have that threat of race conditions. Because, I mean, don't tempt us. We, the staff, will sit there with 2 computers and see if we can't steal some money from your own database implementation. So it's a lot of fun. We'll continue the conversation of PHP and things database related next week as we finally segue to AJAX stuff. Sid will be across the hall for section. We'll see you in a week.